It's Friday, and every Friday morning in your podcast application, it's the AWS Developers Podcast. Today we're talking about the origin of the AWS Lambda service. Good morning, good afternoon, and thank you for listening, downloading the AWS Developers Podcast every Friday in all good podcast applications. Today, I have two special guests, Julian Wood, that you heard already on this podcast. Julian met with Marc Brooker, who was one of the principal engineers at the origin of the AWS Lambda service, and together they talk about the origin of AWS Lambda.
Marc, you were literally there nearly at the beginning of Lambda. Tell us, why did you join Lambda? What was interesting about it? What drew you into the space?
Yes, I've been working on storage. I was on the EBS team at AWS, and I'd really fallen in love with distributed systems and the things that they allow us to do from an availability and scalability and durability perspective. When I looked at that stuff, it was all just so super powerful, but really hard for non-experts to get into. It took a huge amount of expertise for people to build systems using those techniques. And what attracted me to the Lambda team was this idea that we could build those kinds of capabilities into a product like Lambda, offer that scalability, offer the high availability, offer the scale to zero and all of these other things without requiring that people are deep experts in distributed systems architecture, design, techniques, protocols, and all of those other things that go into building systems from the ground up.
How much of that was actually part of the genesis of Lambda? All those things you said, or are some of those properties that have emerged over time that Lambda did these things as well for people? It's an interesting thing of what the genesis of the technology, but this also allowed future things to happen.
Yeah. So, early on in Lambda, I think we were in the privileged position that a lot of our customers almost had a more expansive vision of what we could build for them than we had. There were some things that we were very excited about. We wanted to build a much easier way to build backends for mobile services. We wanted to build a much easier way to build these event-operated architectures. And once we started having customers run on Lambda, they were using it for things that were much more general, a much broader range of things than I think we had originally envisaged, which was just a super exciting place to be for a business, is to have customers coming to us and saying, we want to use Lambda for all of the stuff that you didn't imagine. It's going to be a much more important part of our systems than maybe you had envisioned. Can you help us make that happen? And obviously we were just super excited to say, yes, we would love to help you with that.
And I suppose some of that challenge is also building a service. You have some idea of how customers are going to use it. But if you build a system and you understand exactly how all your customers use it, you probably haven't built the system that is as expansive and inspiring as they possibly could. Customers should surprise you and sort of knock on your door and say you need to do more, bigger, faster, cheaper, whatever.
Yeah, absolutely. It's the best kind of problem to have after launching a product is your customers surprise you with ways they're using it. Bigger, more exciting ways, more critical parts of their business. Asking for real challenging things, and it was just great from a product perspective, and just super energizing for the engineering team to have our customers asking us to solve all of these hard problems on their behalf.
So speaking of those hard problems, you worked in Lambda for many years. What was one of the sort of coolest parts of Lambda, or the funnest thing to work on, or the biggest impact, or something within that Lambda that you thought this is awesome?
Yeah, I mean, there was just tons of stuff that was really exciting. We started off building Lambda with directly on EC2, having EC2 instance per function. That took us a long way, and then we started thinking about should we how do we scale further? How do we improve performance? And that led us to building Firecracker, alongside some other teams at AWS, rethinking the whole Lambda backend, and that was just a fascinating project to work on. And then, the other one that really stands out for me was building container support into Lambda. We started off looking at that almost like it was an impossible problem to solve, right?
Why was that impossible?
Containers are so much bigger than Lambda functions, 40 times bigger. And so we wanted to say, you can bring 40 times more code But we were unwilling, because our customers were unwilling to compromise on cold start latency. And in fact, we wanted to make it better. But moving around code was a big contributor to cold start latency. And so we needed to do almost 40 times more work to load a container in the same amount of time. And
transparently, that customers don't have to configure or do anything.
Right, completely transparently, without adding complexity for customers. In fact, simplifying a lot of things for customers because they could use the tools they were familiar with in the container ecosystem. And those kinds of innovating within constraints like that is the kind of engineering that I find most, inspiring to do, and the kind of building that I think our teams get most excited about is solving these almost impossible problems for customers, just fitting a lot more stuff into less space.
How do you think about this whole event-driven architecture story with Lambda as well? You spoke about web and mobile backends. Some of the genesis of Lambda is a function that triggers when an S3 object was uploaded, and that was one of the genesis where I think smartly AWS looked at that problem and said, "Oh, sure, we could solve running some code when S3, but that could be an S3 object was uploaded, but this could be way more general." And so, the whole sort of event-driven architecture came about, which is also a difficult architectural paradigm for people to think about. How do you think about event-driven architectures and what the power of that is?
Yeah, and a little bit of the context at the time was, folks had moved into service-oriented architectures and then microservices, and very much at the time we started thinking about Lambda, microservices were kind of the way that people were building systems. And then there were these more emerging patterns with the event-driven architectures and CQRS and event sourcing and so on. And one of the really hard things about building those kinds of systems was figuring out how to scale them, because the traditional patterns of auto-scaling and the traditional patterns of load balancing and so on don't work well in those architectures. Right? Something like S3 can go from very little traffic to vast amounts of traffic. And so keeping up with that with a compute architecture required a bunch of smarts on customers' behalf, and we wanted to make that easy. We wanted to make it easy to do, what is, I think, one of the core things in computer science, right? Like something happens and we want to react to that and make something else happen or make multiple other things happen. I think over time, what we've seen is, event-driven didn't take over microservices in the way that some folks were saying at the time. And instead, what we've seen is customers building these hybrid architectures that combine the best of microservices, the best of monoliths, and the best of event-driven approaches to solve different kinds of problems and having all of those things work together. And I think, that's a huge benefit of being in AWS, is that you have a broad number of architectural choices available to you all in one place. You can put those things together.
I suppose the challenge with AWS is to make those different architectural choices easier and work better together and not necessarily be consumed in the same way, but sort of the Lego bricks that we really talk about building, but make them fit together in new ways.
Yeah, that's exactly right. And so, we want to make it as easy as possible for our customers to make the kinds of pragmatic engineering decisions that are best for their business and best for their customers and best for the problems that they're trying to solve, and have a toolkit available to them that allows them to pick the best solution in each space, but have those things still come together to be managed together and controlled together, get the security story right together, and all of those pieces.
So working in Lambda, you moved on to other parts. You've also worked on own databases and now working in AI/ML. What sort of lessons from working in Lambda are applicable or have you taken on in your sort of future journeys after Lambda in AWS?
Yeah, I think the core idea of serverless and the core idea which started at AWS really with S3, kind of in the beginning of AWS and SQS, right? Those earliest AWS services were serverless. And the core idea of, hey, we want to take all of these hard problems, we want to put them into a service to solve them on customers' behalf, is something that we have carried forward with things like Aurora Serverless V2, and most recently in Bedrock, right? You can run these cutting-edge AI models, do cutting-edge inference in Bedrock without having to worry about infrastructure at any level, right? That is a completely serverless system, which, our customers find extremely simplifying as they try and build Gen AI applications.
I suppose there are two aspects to that. Even though we don't necessarily talk about some of these services that are just available as serverless. Bedrock is inherently serverless from a consumption model, but it's also built on serverless technologies under the hood. So there's a sort of consumption part that's serverless, and also, the underpinnings of Bedrock and a lot of other services are also serverless under the hood.
Yeah, and that's right. And, it's because, we love having our teams build on serverless. It saves us internally a whole bunch of time, and allows us to take advantage of the expertise on a team like Lambda. They can solve those hard problems, and a team like Bedrock can focus on the things that they are building for customers, which is, this great Gen AI inference capability without having to worry about low-level compute. And so the value that we talk about Lambda offering to customers is the same thing that it offers to us internally. And that's why we're so excited to build on Lambda, to build on S3, to build on SQS, to build on EC2, and to use that power of the cloud in our own, inside our own product.
Yeah, now I think it's a testament to the power of serverless that AWS, whose teams can choose a number of different architectures as well. No one's mandating serverless, but choose to build serverless because that is the sort of easiest option. And it's not just AWS, it's, third-party partners who are building amazing services, and under the hood, there are a lot of serverless services.
Yeah, and it's just been super fulfilling since the early days of Lambda to see how many people have picked that up and the broad set of things that they've done, partners and customers have built with Lambda. It's just beyond what we imagined at the time.
I just had a question and I blanked. I know we're not going to do this in one roll, so get it. Serverless in 2024, and you quite rightly said that, serverless started with SQS and S3 in a way for AWS. I sort of jokingly say the cloud was born serverless, and then somebody figured out we had to also rent those virtual machines after that. But, serverless terminology only came out after Lambda came out. And so that's sort of 10 years of the serverless movement. And some people are saying, well, serverless is now, dead. Serverless isn't interesting. The next wave is Gen AI. How does one think about what serverless means in 2024?
I think serverless has been so successful that it, is ubiquitous, right? It's completely changed the way a lot of folks, approach building. And I don't think it's reasonable to believe that, serverless will be the only model for building compute systems, only model for building storage systems. Folks have different problems that they need to solve in different ways. But serverless hasn't gone away. It's just become part of the fundamental way that people approach building. We're obviously super excited about Gen AI and all the capabilities we have to offer there. But I see serverless as being this major enabling technology for Gen AI, and not only because things like Bedrock are serverless, but because the kinds of agentic applications that you're going to build with Gen AI, those applications built, using agents, using models, using Gen AI, those don't want to be built on infrastructure that you have to worry about. They have to be built on infrastructure that is automatically managed. So things like agents can decide, I need to do a bit of compute here, or I need to send this message and have it processed. I need to handle this event in this particular way. And by taking advantage of their serverless infrastructure, it becomes just much easier to build and scale those agent-based Gen AI applications. And I think that's just super, super exciting kind of second or third act for serverless as being the core compute platform for Gen AI applications.
Cool. Actually, one thing, having worked on Lambda for so many years, you make architectural decisions at the beginning that you hope are going to pan out and turn to be right. And there are many things that you can rebuild. You talked about, Firecracker and kind of things because Lambda couldn't carry on existing on EC2. If you had to wave a magic wand back 10 years ago and do something different or change the way Lambda worked, how would you even think about the trade-offs that were made that could have been done differently?
Yeah, I think we're just mostly just thrilled with the way that things worked out. Worked out better than we might have reasonably imagined at the time. And so there's nothing that major. I think there are some things, like investing and getting really serious about cold start latency. I think we waited longer than we should have on that. Until we were just really hearing from customers it was this major pain point. I I think we waited too long to make things like Java really fit nicely into that serverless ecosystem, and should have had a start on that, earlier. But it's those kinds of product priority decisions that are just easy in retrospect to think about. Then maybe I would go back and do it in a different order, knowing what we know now.
And there's obviously some of those technologies. For instance, Snapart for Java required some of the technology that was built for OCI. So it's not as though these are just separate features that aren't linked together. Lambda's a big package bundle of a lot of stuff that's going on, and they all sort of rely on each other under the hood.
Yeah, that's right. And Snapart was a super fun one because we kind of sketched out the vision to that early when we started doing Firecracker in 2018. And it was this just multi-year vision of, we need to do Firecracker, and then we need to do the container loading data plane and learn how to move the data around in large scale. And then we need to build the snapshotting capabilities, and we need to figure out how to do that securely. And we had to get some changes into the Linux kernel and changes into OpenSSL. And there were just a lot of pieces. And it was really cool to see all of those kind of come together into that Snapstart product in a way that we had been slowly working towards over, at that time, 4 years.
So it's years and years of work, and then for a customer to use it, it's just a checkbox going enable Snapstart.
Yeah, I mean that's the dream. I think that's what the outcome that we love with serverless is we do a huge amount of innovation, we build a huge amount of stuff under the covers, and to customers, it's just a checkbox, or it's just, today things are faster than they were yesterday.
And do you have a birthday message for Lambda? 10 years for Lambda.
Like, oh, now let's do the same years. I mean, it's just incredible. When you reached out to me to say 10 years, I kind of just didn't believe it for a while. It feels like it's so new. It's still kind of, I think it's still, to use the cliche, it's still day one for serverless. It's such an exciting, technology. It's such an exciting technology direction. I think we're only just seeing the influence it's going to have across our whole industry. And I can't wait for the next 10 years. I think it's just going to be even more exciting.
It's interesting you mentioned the impact across the whole industry, because obviously AWS has been doing a whole bunch of serverless kind of things, but I know that, broadly across the industry, we would love serverless to be a more recognized term or something that people can latch onto. So how would you inspire other builders, where you're creating something anyway, to think of serverless?
Yeah, and I think it, for me, serverless is rooted in, customer obsession and obsession about developers and what they want to care about. And folks, some people love caring about infrastructure, and that's fantastic. But a lot of developers and a lot of businesses just want to solve their customers' problems, right? They want to solve their business problems. They don't want to have to, solve all of these kind of hard computer science problems on the side because they're a distraction. And that's been what's attracted me to serverless. And I think that's why almost across the industry, and especially across the database industry, what we're seeing is customers going to vendors and asking for serverless. And, I want that billing model. I want that operational model. I want just fewer knobs, fewer things to worry about. And so, I think that's just where the industry is heading. And if we end up calling that serverless, that's great. And if we end up calling it something else, that's great too. And it's really the outcome that excites me.
Excellent. You're now outside of the Lambda team. What are you sort of knocking on their door saying they need to be building next? Or what's the sort of next challenge or the next opportunity or the next thing to build for Lambda?
Yeah, I mean, the thing we ask about is those pieces of infrastructure for generative AI. We a few weeks ago launched Code Interpreter for Bedrock. That's built on a lot of the Lambda technology. That was a partnership with the Lambda team. And we want to build a lot more things like that. And we're continuing to partner with that team to build more and more compute capabilities in Gen AI, in Bedrock, in Q Developer, in Q Business. And the vast majority of that stuff is going to be powered by serverless because it's just such a great fit. It's like this sort of chocolate and peanut butter with Gen AI. and serverless.
Thank you, Marc. Thank you, Julian, for having driven this interview. And thank you for having listened this episode of the podcast until the end. See you next week for a new episode. But now, go build.